It's not.
All right, here we go. Polar coordinates. Polar coordinates. I'll either let you learn from me or I'll let you learn from the book. Prefer probably from me. I'm telling you, I'm like feisty today because I just got a lot to do. Okay, so you will need to be able to understand that polar coordinates and the polar graph looks very different than what you've graphed before. What's wrong? Okay. A fixed point O, so that's right here. This is called the pole. That's called the pole. It's where it starts. Okay? The pole. Then from the pole, you always draw a ray. Okay? That's called your polar axis. Okay? So what's happened here is this is my pole. There's my starting point. There's my polar axis. And I've gone up some angle measure. Okay? So when you graph polar points, it will always be in the form r theta. R being the radius, theta being the angle for which you are graphing it on. Okay? R is the directed distance from 0 to P, so that's your radius, because we were talking about a circle. Your theta is your counterclockwise angle, just like we've always talked about. Okay? Counterclockwise, first, second, third, and fourth. Yeah? Okay? Is everybody okay with that? Okay. We'll just stay there. Okay. Here's what a polar coordinate graph looks like. The inner rings are solid numbers, like 1, 2, 3. So like this point right here is 0, 0. Caleb, you're really going to want to listen and watch. Like you don't know how to graph this. Then 1, then 2, then 3. Does everybody see what I mean by that? Okay. There's 0, 0. The rays coming out go with angle measures. So this is 0 degrees. This is pi over 6, pi over 3, pi over 2. 4 pi over 3, 5 pi over 6, pi. Yes? Notice what's not on there is pi over 4. So pi over 4 is halfway in between pi over 3 and pi over 6. So here's how you are going to graph it. This is your radius. That's your angle. Yes? So 7 pi over 6 is in what quadrant? Huh? The third, right? Because it's one bigger. So if it's in the third quadrant, 7 pi over 6 is on this line. Because that's in the third quadrant, that's your pi over 6. Yes? Okay? So that point is going to be right there. 2, 7 pi over 6. Point 5, 3 pi over 4. What quadrant is 3 pi over 4 in? It's in the second quadrant, right? 3 pi over 4 is halfway in between 4 pi over 3 and 5 pi over 6. So that's going to be right around here. Yes? Does everybody see where I am? 0.5 is halfway in between 0 and 1. There's point B. Halfway in between. Pi over 4 is never going to be on there. You're going to have to go halfway in between. C, what's the difference? What? What's negative? Your pi over 3. If your angle is negative, where does it belong? What would I do if I gave you a negative angle? What would you do? You would add 2 pi, right? So this is the same as 3 comma what? What's 2 pi in terms of thirds? 6 pi over 3, right? 6 pi over 3. So this is the same as 3 comma 5 pi over 3. Agree or disagree? Agree. All right. So what quadrant is 5 pi over 3 in? It's in the fourth quadrant. 5 pi over 3 is going to be this line right here. And I need to go 1, 2, 3. There's C.
I have a question.
Yeah.
For the lines that go up and down, how do you know where to put that? Like, what does that have to do with it?
What do you
I
mean?
don't understand. So you see how A is on the
Yep.
second ring?
Yep.
How do you know which ring to put it on?
Because each solid ring, so like this is 0, that ring right there is 1,
Oh.
then 2, then 3.
How are we doing? Where to put
Where the angle is?
Yeah.
Okay. Pi over 6, pi over 3, pi over 2. 2 pi over 3, 5 pi over 6, pi. 7 pi over 6, 4 pi over 3. I would write these down. Those of you that are not, it's a bad idea. 5 pi over 3 and 11 pi over 6. Okay. Now, what's different with D that I haven't had yet? Right. Now, that's not an X. Be careful. That's R. R and theta. The notes are up front. R and theta. Can you have a negative radius? Are you allowed to have a negative radius? No, right? You're not allowed. So here's what you do. You go the opposite way. So think about, where is pi over 4? What quadrant is pi over 4 in? It's in the first. So it's halfway in between here. So it's kind of along like that right there, right? Yes? So if I told you it was 1 pi over 4, you would come and mark it right there. Agree or disagree? Yes? If it's negative 1, you go the opposite way. So I can take this pi over 4, I can draw it through there, as well as it's through there. I can make that diameter. Yes? Yeah? Okay. So if it's a negative radius, you're still going to your pi over 4, but go the opposite direction and make it the 1. Okay. E. Go to your angle first. What angle am I going to? On E, what angle am I going to? 4 pi over 3. So if I'm at 4 pi over 3 and it was positive, I would be right here, correct? But I need to go the opposite direction. So go 2 and then go 2 more. There's E. There's E. Try F for me, please. So you're here, you're at 3. That should be all the way up there. Should be up here. This is negative, yes? Make it positive. So what do I add? 12 pi over 6. So this is the same as negative 3 comma 11 pi over 6. Yes? Agree? So I would go 3 here, but it's negative, so I have to go in the opposite direction.
Oh, I thought since it was opposite or negative, you
The negative and the R is what causes it, not anywhere else. All right, we ready? Ready? All right, now, sometimes I'm going to ask you for multiple representations of the same angle, which can happen all the time. So, we're going to take our R theta, and we can represent them different ways. Sorry, I'm like starting to fade. I'm tired. We can represent them different ways. So here's how you're going to do that. You can keep your R the same. And add 2 pi n. That's one way of doing it. Or you're going to flip your R. And you're going to add pi. I should say plus or minus pi. Let's say plus or minus pi. Okay. Now, we're going to give 3 different pairs of polar coordinates given between negative 2 pi and 2 pi. It's just the front of the notes, and then that's it. Negative 2 pi, 2 pi. So here we go. Is my R currently positive? It's currently positive, right? So if I want to keep my R positive, I have to add 2 pi n. Or subtract 2 pi n. Right? Because n could be positive or negative 1. Does that make sense? Yes, no, maybe. Okay. Well, if I take this angle, which is 5 pi over 3, if I add 2 pi, what would I be adding? You'd be adding 6, right? So that's 11 pi over 3, correct? Is 11 pi over 3 greater than 2 pi? Yeah, because 2 pi is 6 pi over 3. Does everybody see what I mean by that? So can I add 2 pi to stay within this range? No. Well, what's the other option? I could subtract 2 pi. Well, what's 5 pi over 3 minus 2 pi? It's negative. Negative pi over 3. Is negative pi over 3 between negative 2 pi and 2 pi? Yeah. So for this one, I did R and I did theta minus 2 pi. And that gives me 2 comma negative pi over 3. Okay, that's one. It's one of them. Yes, no, maybe. We good? Okay. Now, you're only going to be able to get one of these. You're not going to be able to get, the other two are going to have to come from here. All right. So let's do negative R, and we'll do my theta plus pi. What's my current radius right now? What's my radius in my original problem? 2. But what do I want to do with the radius? You want to flip it, right? Okay, so it's going to become negative 2, comma, well, am I adding or subtracting pi? There's my hand. What am I doing? Adding pi to what? My original angle, okay? Theta plus pi. Does everybody see what I mean by that? What is pi in this case? 3 pi over 3, yes? Yes? What is 5 pi over 3 plus 3 pi over 3? 8 pi over 3. Is that out of my range? Yeah, so I can't add pi. So try subtracting pi. 2 pi over 3, is that in my range? Yep, so there's 1. I need another one, right? Keep subtracting pi. Negative 2, comma, we'll subtract pi again. Negative pi over 3.
Oh, so you just subtracted from each. Oh.
Okay. Yes? Okay, let's try the next one. Guys, find this one first every single time. It's the easier one of the two. Keep your radius the same. So what's my current radius? Negative 5, okay? Negative 5, comma. Now, think logically here. My current angle is what? Negative 7 pi over 4. If I subtract 2 pi, am I going to be within where I need to be? No, I'm going to be way back, right? So can I subtract 2 pi at all? No, I need to do what? Add 2 pi. Well, if I add 2 pi, what's pi in this case? Or I'm sorry, what's 2 pi in this case? I apologize. 8 pi over 4. So what is negative 7 pi over 4 plus 8 pi over 4? Pi over 4. There's your first one. That's keeping my radius the same, yes? Okay. Now what do I need to do? I need to flip it. So my radius is now going to be 5, comma. We should really add a plus or minus 2 pi on here. Yeah. Change that. Have this one read like this. Have it read like that instead. Okay. Can n equal 0? Yeah, n can equal 0. It's okay. If n equals 0, you're just going to add pi.
I thought it was only negative 1.
What do you mean?
I thought it was, or, yeah.
Huh?
N?
Right here. See that n right there?
Yeah. I thought it was just plus or negative 1.
It can equal 0. N to any integer. 0 is an integer. So, it means flip my r. Did I flip my r? What do I do with my angle? I now add, so this is going to be like this. Negative r, theta plus pi, boom. Because n is 0. Does everybody understand that? If n's 0, this whole thing goes away? Yes? Well, what's theta? Excuse me, what's theta plus pi? What? What's pi in terms of fourths? 4 pi over 4, yes? So what's negative 7 pi over 4 plus 4 pi over 4? You got it. No, I didn't. If that's what you said, I'm sorry I didn't hear it. Okay, sorry I didn't hear it. Okay, now, here's where you have to think logically again. My original angle, is it positive or negative? Negative. So can I keep subtracting 2 pi? If I keep subtracting 2 pi, I'm going to go out of my range, right? So I'm going to have to do what? I'm going to add 2 pi. So this is going to be when n equals 1. So it's going to look like this. Negative r, theta plus, well, guys, if n equals 1, what does this? This is just 2 pi, right? So this is going to be plus 3 pi. Because pi plus 2 pi? Yes? Because n equaled 1. Yes, no, maybe. Yeah? Because you got to find two angles. I'll do another one. I'll do it on the back with you again. Okay? Well, what is 3 pi in terms of fourths? 12 pi. Go back to your original angle. Negative 7 pi over 4 plus 12 pi over 4. So what is negative 7 plus 12? 5. Do you want to do one more of those on the back? So we got that. We can do this for me in a second. Pick two of them between 7 and 10. Maybe I'll do one of them with you. Maybe two. Pick two of them. 8. Okay. 2.5 and negative 4 pi over 3. So going back to where I'm going to do it on here. All right. So we have keep R the same, right? And what do I do with my theta? You add 2 pi n. Or I switch my R. I take my theta, I add pi, and I add 2 pi n. Those are my two options. You just have to know that. Those are my two options. Okay? Now, start with this one first. Yes? What's my radius going to stay at? 2.5. Now, here's where you got to think. Is my angle positive or negative to begin with? Negative. So if I subtract 2 pi, am I going to be between negative 2 pi and 2 pi? No. So if it's negative, you're always going to do what? Add. If it's positive, you're always going to do what? Subtract. So this time I want to take my angle and I want to do what with 2 pi? You want to add it. Well, what is 2 pi in terms of thirds? I heard it. 6 pi over 3. So this is going to be 2.5, comma, what? You got it. 2 pi over 3. Does that help clarify that one? Okay. Now, we're going to do this one how many times? Twice. You always do the negative one twice. Okay, so here's my original, yes. What's my new radius going to be? Negative 2.5. And the first one you always want to do is when n equals what? 0. Every single time. So if n equals 0, am I dealing with this at all? No, okay? So now what do I need to do? I need to take my angle, which is negative 4 pi over 3, and I need to add what? Add 3 pi over 3, yes? So negative 4 plus 3. So that's negative pi over 3. No, does that make sense though?
Yeah. But I just didn't like the sound when I was.
Oh, okay. No, that's fine. I just want to make sure. That makes sense? Okay. Now, go back to the original angle. Is it positive or negative? Negative. So am I going to make n 1 or am I going to make it negative 1? 1, because you need to get it bigger, right? So n equals 1. Well, if n equals 1, you're going to have negative 2.5, comma, my original angle, plus pi, plus 2 pi. Because now n is 1. Does that make sense? So this is now negative 2.5, comma, negative 4 thirds, plus 3 pi. Are you okay? You just did a shiver, that's only. What's 3 pi in terms of thirds? 9 pi. So it's negative 4 plus 9. Yep. So negative 2.5, comma, 5 pi over 3. So there's 1, there's 2, there's 3. Yeah?
Oh, why did you choose?
You need 3 different pairs.
Oh,
Right, boom, boom, boom. They should all have different angles. Do you want to do one where it's negative, or you want me to teach you the last thing? Do one where it's negative. Okay, which one? We'll take off 10. You guys want to do 10. It's stupid that I put that on there. 9? That's the only one we can do. All right, what is it? -1, -5 or 6. Okay. Is it helpful that I wrote those 2 things up there? Okay. So, r, comma, theta plus 2 pi n. And then -r, theta plus pi plus 2 pi n. All right. Which one do we have to do first? The first one. So it keeps my radius the what? Same. So my radius is going to stay at -1. Now, be honest. Can n equal 0 here? No, because it's exactly to where it is, right? So n has to always equal either 1 or -1. Does that make sense? Because you're going to add 2 pi or subtract 2 pi. Now, is this positive or negative? So am I going to add 2 pi or subtract 2 pi? Add. Well, what's 2 pi in terms of 6? 12. So I'm going to add 2 pi. So this is the same as -1, comma, 11 pi over 6. There's your first one. Yeah? Are we cool with me here? Okay, what do I have to do on this one first? Well, you're going to let n equal 0 first, right? Always. Okay, what am I flipping?
So why is it 0?
Because you're going to, like, n can be any number from negative infinity to positive infinity. But starting with 0, you have less work to do. And then the next one will either be n equals 1 or -1, depending if it's positive or negative to begin with.
So do you have to start with 0?
I would always suggest you start with 0. No.
Okay. I was just wondering.
But if you start with like 1 and 2, you're going to get out of your range. So I would always start with 0 and then 1 or -1. Okay, what's my new radius? 1. Everybody cool with me there? So it's going to be 1, comma, my angle, so negative pi over 6, plus pi. Because n was 0. Yeah? What's pi in this case? Huh? 6 pi over 6. So this is 1, comma, 5 pi over 6. There's 2. Now tell me, are we going to do +1 or -1? Why? Now, if you subtract 2 pi, are you past your 2 pi limit? Remember, if it's negative, you always want to make it positive. So you're going to do n equals +1. Because if you subtract 2 pi, you're past 2 pi, because that'd be -13 pi over 6, which is outside your range. So it's going to be 1, comma, negative pi over 6 plus, oopsies, pi plus 2 pi, because n is 1. 1, comma, negative pi over 6 plus 3 pi. What's 3 pi? 18. This one doesn't work, does it? Oh, we should have subtracted. Is that what you did?
You said -1?
Did you know why, though?
No. Oh, no, the reason I said -1 is because they were both negative, and I thought it would make sense.
Subtract pi.
But what you guessing?
Sometimes keeps having a day. -7 pi over 6.
Why is it -1 now?
Because this is still a positive one, and you're making n negative 1, so it's pi minus 2 pi, which is negative 1 pi.
No, but why are we doing negative 1?
Because if you add 2 pi, you're too far off of it. That's a, if I were you, that's a, try it n equals 1. If it's past 2 pi, then go to n equals negative 1. Then go to n equals negative 1. There's one last thing that's on that paper. One last thing, distance formula. Here's your distance formula for a polar. It is this. We don't have, that's slope. We don't have x's and y's. No. Completely different. Completely different. Why? Oh my gosh. This is like straight in your calculator.
Over cosines and tangents and sines and cosines and
Not even close. Not even close.
So
I didn't
that's
stutter.
Stuck with us for the rest of the year.
Yeah. The next at least 3 weeks.
Yeah.
That's why you get along with me so well.
Yes, I do.
All right, we're just doing one. Distance formula. Square root. R1. So either radius, it doesn't matter. So my first radius is 2, so this would be 4 plus 9. Yes? Minus 2 times, oopsies, 2 times 3 times the cosine of 7 pi over 4 minus pi over 3. You may use your calculator for this, but if it is in radians, you have to make sure your calculator is in radians as well, because you guys are not going to know these angles. So make sure it's in radians. So it will look like this. Square root 4 plus 9 minus 2 times 3 times the cosine of 7 pi over 4. I need pi. Minus pi over 3. 4.01. Oh yeah, she just dropped this class.
I see her in the hallway after this.
Is she gonna be